Every year, the world throws away more than 1 billion tires. That's right, 1 billion. The terrible thing is that they don't decompose naturally. Burning them is toxic. Burying them takes up too much space. Tires are one of the most difficult types of waste to deal with on the planet today. So how do people handle them? Do they just let them overflow into landfills? In this video, you'll learn how people turn these discarded tires into something that generates money. Did you know that the world's largest tire dump once contained over 50 million old tires? So large that they were visible from satellites? The scary thing isn't just its scale, but also the danger these mountains of rubber can pose to the environment. Just one fire could turn the entire tire dump into one of the world's most difficult fires to extinguish. Because they contain large amounts of hydrocarbons, tires can smolder for days, even weeks, generating extremely high temperatures and huge plumes of black smoke, carrying fine dust and many toxic compounds that are released into the atmosphere. Meanwhile, melted rubber also forms oil that can seep into the ground or be carried by rainwater into rivers and lakes, causing long-term environmental pollution. Because of these risks, many countries have restricted or banned the landfilling of whole tires and invested heavily in modern processing technologies. The recycling journey begins with a collection network spread across the United States. Every day, approximately 800,000 expired tires are collected from tire shops, repair garages, commercial vehicle fleets, scrap yards, and local collection points before being transported to recycling facilities. After arriving at the factory, the tires undergo a sorting process based on their condition before entering the processing line. Not all old tires are immediately crushed. Workers carefully inspect the tread, sidewall, and internal structure to determine the extent of damage. Those that still meet the standards are separated for retreading or reuse, extending their lifespan. Only tires that are excessively worn, torn, cracked, or structurally damaged are sent to the recycling line. To support the collection of old tires, many states apply a processing fee when people buy new tires, typically ranging from about 25 cents to $2 per tire. Thanks to this system, approximately 80% of end-of-life tires in the US are currently recycled or reused, making the country one of the world's leading tire processing rates. As mentioned earlier, if the tire's sidewall is still in good condition, factories prioritize extending its lifespan through retreading technology. Before being sent to the retreading line, each tire undergoes a rigorous inspection process to assess the quality of the casing, also known as the tire sidewall. This is the part that bears the entire load of the vehicle and determines whether the tire can continue to be used safely. Technicians inspect both the inside and outside to detect damage such as cuts, tears, bulges, deformations, or signs of structural damage that may be overlooked by the naked eye. But how can a new layer of rubber adhere to a tire that has been used for many years? The answer lies in the buffing process, also known as grinding away the old tread. The tire is mounted on a specialized lathe and rotated at high speed, while a hard alloy grinding head slowly removes the worn rubber from the surface. This process not only removes the old tread, but also creates a highly uniform rough surface, allowing the new rubber to adhere firmly to the casing in subsequent steps. After completion, all rubber dust is vacuumed up, leaving a completely clean surface ready for repair and new tread application. Grinding away the old tread also reveals any damage that the tire has accumulated after tens of thousands of miles of operation. This is when the repair process begins. The damaged rubber is first cut away to create a clean and stable surface. Depending on the extent of the damage, small cracks are treated with a specialized rubber compound, while larger punctures require filling with rubber and reinforcing with high-strength technical patches. Afterward, the repaired area is sanded smooth to match the entire casing surface. In many modern factories, The casing is also re-inspected using electronic or X-ray systems to detect hidden damage invisible to the naked eye. Thanks to this process, a casing can be recycled up to 3 times while remaining safe, saving up to 70% of materials compared to producing new tires. After the tire casing has been restored, it remains a plain tire unusable on the road. To restore the tire's original grip and performance, factories must install a completely new tread pattern. Currently, factories mainly use 2 methods: pre-cure and mold cure. With the pre-cure method, the tread pattern is pre-manufactured with a complete design and then cut to the exact circumference of each casing. Before installation, the tire surface is coated with a layer of cushion gum, an unvulcanized rubber with very strong bonding properties. The tread strip is then pressed tightly by a roller system to adhere evenly around the casing and completely eliminate air pockets. Meanwhile, the mold cure method uses unpatterned rubber wrapped directly onto the casing before the entire tire is placed in a mold. Under the effect of high temperature and pressure, the rubber will simultaneously vulcanize and form new tread grooves. But for the new tread layer to not just adhere to the surface, but truly become a part of the tire, factories must perform the vulcanization process. First, the entire tire is sealed with an elastic rubber membrane combined with specialized air pockets to create even pressure across the entire surface. Then, the tire is placed in a vulcanization chamber, where the temperature is usually maintained at around 200 to 250 degrees Fahrenheit and high pressure. Under the influence of heat and pressure, the cushion gum layer begins to vulcanize, creating a strong bond between the new tread layer and the old casing, transforming them into a nearly unified structure. After completion, the tire undergoes a series of quality control checks. Technicians will inspect the appearance, measure concentricity and balance, and many factories also use chirography or X-ray technology to detect hidden defects. Only tires that pass all inspection standards are shipped, ready to serve tens of thousands more miles on the road. Retreading is only applied to tires that still retain sufficient structural integrity. For most tires that have reached the end of their service life, the entire structure is broken down to recover individual materials for use as fuel in the cement industry. Before shredding, the tire must have its steel bead wire removed, the thick metal ring at the edge of the tire that holds it firmly to the rim. Specialized machines will clamp and pull this steel wire out, leaving the pure rubber. The recovered steel is collected and sold as scrap metal, returning to steel mills for reuse. Once the steel bead wire has been separated, the tire begins a multi-stage shredding process to recover each type of material inside. First, the tire is fed into a primary shredder, where 2 counter-rotating blades with extremely high torque slowly shred the tire into pieces approximately 4 to 12 inches in size. The rubber pieces are then transported by conveyor belt through a magnetic system to separate most of the remaining steel wire before entering a secondary shredder. Here, the material is further cut down to about 2 inches. If rubber granules are needed for sports fields, asphalt, or molded products, the material goes through several more shredding and screening stages until only ultrafine particles less than 1 inch in size remain. Between each stage, high-powered magnets and an air suction system continuously separate the steel and fabric fibers from the rubber. After shredding and separation, the tire is divided into several separate material streams. Among these, the rubber is often used as an alternative fuel for cement plants. The rubber pieces are fed into a clinker kiln at a temperature of approximately 2,500 degrees Fahrenheit, where they burn almost completely, releasing a large amount of heat to partially replace coal or fossil fuels. The remaining ash is not discarded, but mixes with the clinker, becoming part of the cement. Thus, both energy and material in the tires are efficiently utilized. Not all recovered rubber becomes fuel. A large portion is recycled into crumb rubber, opening up many new applications in construction and daily life. In the transportation industry, rubber granules are mixed with hot asphalt to create rubberized asphalt. This mixture makes road surfaces more durable, reduces cracking, and limits noise from vehicles. Another portion is pressed to produce rubber sheets used for gym floors, playgrounds, and many impact-resistant surfaces. Smaller rubber particles are mixed with binders and molded into elastic coatings for sports fields or running tracks. When further ground, they can become raw materials for shoe soles, rubber tiles, and many other industrial products. From a tire that seemed to have no value left as waste, recovered rubber has been transformed into a range of new materials, continuing to serve in transportation, sports, and daily life. Besides mechanical grinding and retreading, pyrolysis is another recycling method that is gaining increasing popularity. Instead of direct incineration, tires are heated in a sealed chamber at approximately 1,000 degrees Fahrenheit in the near absence of oxygen. Under these conditions, the rubber does not burn but decomposes into three main products: pyrolysis oil, gas, and carbon black. On average, 1 ton of waste tires can produce over 100 gallons of oil, which, after refining, can be used as industrial fuel. The generated gas is usually returned to the furnace to maintain heat, reducing the need for external fuel. Meanwhile, carbon black, which accounts for about 30% of the tire's weight, is recovered for use in the production of rubber, plastics, and paints. This technology has already been implemented in hundreds of factories in China. However, if the exhaust gas treatment system does not meet standards, the pyrolysis process still risks releasing toxic compounds into the environment. From an item that seemed to be just waste, old tires can be recycled into new tires, transformed into construction materials, industrial fuel, and a range of products for daily life. This also proves that with the right technology, even the most difficult-to-process waste can become valuable resources. If you found this journey interesting, don't forget to like, leave a comment about the process you'd like us to explore next, and subscribe to the channel so you don't miss the latest videos. Thank you for watching, and see you in the next video.